chapter 10 problems in the guide. Yes. Okay, problem number, your name is Ian, right? Ian is asking problem number 3 from the study guide in chapter 10. I made a mistake when I was doing this problem earlier today in the other section. For some reason I was thinking polar coordinates when I was doing this in my head, so I made a mistake. But here is the problem. X is what I'm going to do is I'm going to actually switch the x and y values, and the reason is when I worked out this problem, I gave an answer, but the answer only worked if I switched x and y, and then at the end I switched x and y. I'm going to do that here, but then I'll also do without switching x and y. Okay, so this is sine half t. So x is cosine half t, y is sine half t, and t is between negative pi and positive pi. So that's the curve. So first of all, the first question is eliminate the perimeter and come up with an equation in x and y, right? So how do I do that? Anyone has done that problem? How do I eliminate t? How do you eliminate t? Very good. So you take the square, x squared plus y squared. X is cosine of half t. So that's squared plus sine of half t squared. What is sine squared plus cosine squared? So we know that x squared plus y squared is then 1. So we know that the curve is basically part of the circle. So let me make a circle here. Let's say the center is right here. Okay, so this is the circle centered at the origin with radius 1, right? Okay, now the question is how is this curve traced, and also are we tracing the entire curve as t going from negative pi to positive pi? That's what we need to determine, okay? So how do I determine whether I am how do I determine how I'm tracing the curve and what part of the curve? Am I making sense? So we know certainly that the curve is part of the circle. So what I do is I look at the interval for t. So let's look at the interval for t. T goes from where? Negative pi to positive pi, right? And what I want to do is how x and y are increasing and decreasing as functions of t. Am I making sense? How do x and y increase and decrease as functions of t. So I am going to pick an intermediate point 0 here. First of all, when t is between negative pi and 0, notice that half t is between negative pi over 2 and 0, right? So then, you remember what is x and y? X is a cosine of half t, right? If x is cosine of half t, right, then how does x behave? Well, what is the value of x when t is negative pi? When t is negative pi, x is cosine of negative pi over 2, which is what? 0. And okay, and what is the value of y? It would be y is sine of half t, so t is negative pi, you get negative 1. Please to get negative 1. Okay, as t goes from negative pi to 0, half t goes from negative pi over 2 to 0, which means half t is in the fourth quadrant, and in that quadrant the cosine value, half t is going from negative pi over 2 to 0. In that interval, cosine of half t is, what's that? Increasing, and it's increasing to what? Increasing to, well, x becomes 1 here, right? Cosine 0 is 1. And then what is y? What is the y value at t equals to 0? Sine 0 is 0. So what's happening is that x is increasing here. The x value is increasing here. The y value is increasing here as well, right? Okay. Everybody is okay with that, because when t is between negative pi and 0, half t would be between negative pi over 2 and 0, and in that interval, sine of half t is increasing from negative, in that interval, sine of half t is increasing from negative 1 to 0. Cosine of half t is going from 0 to 1, right? Everybody is okay with that. Okay, now what's happening between 0 and pi? Well, when t is between 0 and pi, half t is between pi over 2 and 0. So half t is varying in the first quadrant. So what is happening in the first quadrant? In the first quadrant, we know that cosine of half t will go from what? 1 to 0. Because here x would be 0 then, and it is decreasing to 0. Okay? And y value is sine of half t, and that's going from 0 to 1. Because half t is going from 0 to pi over 2, sine of that will go from 0 to 1. So I know it is 1 here, and it is then increasing. Am I making sense? Alright, so at when t is 0, when t is negative pi, where are we? When t is negative pi, I get the point x is 0, y is negative 1, right here, right? This point. And then when t is 0, we get the point x is 1, y is 0 right here. And then when t is pi, we get the point x is 0, y is 1, this point here. And then is it clear that the curve is traced in this way? Because what's happening is that we know that x goes from 0 to 1. X is going from 0 to 1 and 1 back to 0. Y is going from negative 1 to positive 1, right? You see that? So x is going from 0 to 1 and back to, so let me indicate this by this. So x is going from 0 to 1 and then it goes back to 0, right? And what is happening to y? Y is basically increasing. Y is increasing from negative 1 to 0 and 0 to 1, right? So the curve must be traced in the direction of what? Counterclockwise, right? Is that making sense? Yeah.
Why would you take the value of 0?
Oh, the reason I picked it is because well, basically, generally, how would you do it? Well, you just want to find x as a function of t. So remember, x is cosine of half t. I am trying to remember in Calc 1, you are given a function, determine where the function is increasing and decreasing. What did you do? You found the derivative, critical points, and looked at where the derivative is positive and negative and so on. I didn't do that here because I feel like the cosine sine functions, they are well known. So I can just use the basic definition of cosine or sine or their graph in order to come up with where each function is increasing and decreasing. So I sort of knew that the function x is going to increase and decrease and it's going to change at 0.
So it's still arbitrary.
It's not arbitrarily chosen.
It
Yeah.
makes sense to pick 0. It could have been any other. Could have picked multiple points. Right?
Yes, but I put 0 intentionally though. Yeah. Remember, at the end of the day, you want to know exactly where x is increasing and decreasing. So pick whatever points you need to make sure you know exactly how it's increasing and decreasing. And the reason I picked 0 was because I knew that if I break it up at 0, then half t would be in one of the quadrants. And I know how, if an angle is varying over a quadrant, then I know how exactly the sine cosine function behaves. So that's what I'm using. But you don't necessarily you don't have to do it the way that I did. You can find the derivative, critical points. You'll see that the critical point is going to be at 0. And then you'll see where x is increasing and decreasing. Or you could also use the graph. You have a calculator, you can graph the graph of cosine of half t, right? Look at the graph of sine of half t. It's going to tell you exactly how it's, draw it between negative pi and positive pi. It's going to tell you how it's increasing and decreasing, right? Is that making sense? All right, so that's the graph. Now, what if I kept x and y the way they were? Remember, the reason I changed x and y in my morning class is because I messed up the problem, and then whatever my answer was, I changed the problem intentionally so that it matches my answer. But if I kept x and y the way they were, what would you get? That is, x would be sine of half t, y would be cosine of half t, right? So what's going to change in my discussion? Well, in my discussion, then this x will become y, right? This will become y. This will become y. This will become x. This will become x. This will become x, right? So what part of the circle do I get then? What's that? Upper half of the circle. You guys realize that? Okay, so if I kept the problem the way it is in the study guide, you would be getting the upper half of the circle traced from left to right. You guys realize that? Okay, same thing. It's just that switched. Okay, any questions on that? Now, one thing to remember that I'm definitely not putting this problem on the. I mean, I'm going to ask the same question, but the curve, the x formula, y formula, the t values will be different. Okay. Okay, any other questions from the study guide? Any other questions from the study guide? You've done all of them? 1, 2, 3, 4, 5? All of them? Yeah. Yes. Number 5. You have both parts or just one part? Both of them? Okay. The first one is the one which is asking you to sketch the curve, right? So let me do it after I do part B, because I have to bring out my polar coordinates sheet. So I'm going to do the part B first, and then I'm going to go to A. In part B, I have the curve given by R is 3 sine theta, and we are asked to find the slope of the tangent and the equation of the tangent at theta equals to pi over 4. So when theta is pi over 4, you get a point on the curve, and at that point you have a tangent line. What's the equation of that tangent line? So remember, what was the trick for this? You have to express the curve first of all parametrically. That is, you have to write out x as, remember, x is r cosine theta, and y is what? R sine theta. And because r is given to be 3 sine theta, r is 3 sine theta cosine theta, then y is 3 sine theta cosine 3 sine theta cosine theta sine theta, thank you. Sine theta. Okay, and then you need to take the derivative of x and y with respect to theta. You can take the derivative right now by using the product rule if you want to, but I am a bit lazy about it, so I'm going to first of all apply a identity to to express x, to simplify x and y. So x can be expressed as 3 divided by 2 of sine 2 theta. Why is that? Because I am using the formula that sine of 2 theta is 2 sine theta cosine theta. I'm using that formula. And how about the y value? I'm just going to write it as 3 times sine squared of theta. Okay, there is another thing I could have done, which is, remember there is a formula for sine A, sine B, and you can write it as a cosine of A minus B plus cosine A plus B. You could apply that, and then you don't have to worry about that square. But I'll just keep it this way. And then I need to find dx d theta, which is what? 3/2 times the derivative of sine 2 theta is what? What's that? Say it again. 2 cosine 2 theta. So that's pretty much 3 cosine 2 theta. And then what is dy d theta? That's going to be 3 times what? This is what? This is 3 times sine theta whole squared, right? So what's the derivative? 2 sine theta cosine theta. And once again, by applying the sine 2 theta formula, I can write it as 3 times sine 2 theta. Everybody's okay with that? So this quantity that I have here, 2 sine theta cosine theta, that's the same as the quantity sine 2 theta. Now, what's the slope then? The slope is dy d theta over dx d theta. And that is equal to what? You guys agree with that, with me, that this is sine 2 theta over cosine 2 theta. I mean, I can write the 3's, but they cancel out, right? They cancel out. Now, I have to know the slope when the angle theta is what? I need to know the slope at the angle theta equals to pi over 4. So I have to replace theta by pi over 4, right? You guys agree with that? What do I get? Whoa. What do I get? What's that? What's the slope at pi over 4? When theta is pi over 4, what's the numerator? 1. I mean, we are cancelling out the 3. And then denominator? 0, right? Well, so it's undefined. The slope is undefined. But however, what we could say, remember, this means that dx d theta is vanishing, right? So it means that dx d theta is 0 if theta is pi over 4. So it means, what do you have at pi over 4? There is a vertical tangent, right? Vertical tangent at theta equals to pi over 4. Everybody's okay with that? So what would be the equation of the vertical line? Vertical tangent equation would be what? Well, what's the x value when theta is pi over 4? The x value, what is x? Remember, we found x, right? X was this quantity here, right? And what is the x value when theta is pi over 4? 3/2, right? 3/2? Okay, 3/2. If theta is pi over 4, and so the equation of the vertical tangent is given by that, right? That's the equation of a vertical line at 3/2. X equals to 3/2. Am I okay with that? Now, in the exam though, this is actually, unfortunately, when I was quickly making the study guide, I didn't take care of the... So in the exam, I'm not going to give you a situation where you're going to get a vertical tangent. You're going to get actually a slope, actually a defined slope, okay? You're going to get the slope to be some number, and then you have to find the equation of the tangent. My question to you, in that case, how would you find the equation of the tangent? In order to write down the equation of a line, you need a slope and you need a point. If you know the one point on the line, if you know the slope, then what formula do you use? Point slope formula, right? So now the question is, do you know what point? Well, how do you find the point? Well, if it is asking you to find the slope of the equation of the tangent at theta equals to pi over 4, so when theta is pi over 4, what's the x value? What's the y value? That's going to be your point, right? When theta is pi over 4, what's the x value, what's the y value? That would be your point. And then you know the slope from the derivative, and then you write down the equation. Is that making sense? All right, so tomorrow's exam, you should remember that I am going to give you the same problem, but I'm not going to give you a situation where you have a vertical tangent. You'll have a slope which is defined, a number, and you have to use the point slope formula to find the equation of the tangent. Is that clear? Okay. All right. Any questions on this problem, anyone? No? All right. Here's the here's the other. Oops. Here's the other problem, 5a. 5a, you have r to be 1 minus sine theta. I think in the class we did the example with 1 plus sine theta, I think. So this is where you have 1 minus instead of 1 plus. Once again, you have to figure out how r is increasing and decreasing. Okay. So again, because sine theta is a periodic function with period 2 pi, all I have to do is look into what's happening between 0 and 2 pi. This is not true for any function, right? This is true in this case because the function sine theta is a periodic function. So as theta goes from 0 to 2 pi, once you have the curve for these theta values, for other theta values, you get the same points. Okay, so I'm going to go from, let me draw it here. Okay, so I have 0 here and 2 pi here. Let's say I have pi here and I have pi over 2 here, and I have 3 pi over 2 here, right? Okay, can someone tell me what's happening in each of these subintervals? When theta goes from, well, what's the value of r when theta is 0? What's the value of r when theta is 0? 1. What's the value of r when theta is what? Pi over 2? What's that? Sine pi over 2 is 1. So this is 0. When theta is pi, 1. When theta is 3 pi over 2, 2. Because sine 3 pi over 2 is negative 1, so 1 minus minus 1. And then the last one here, 1. Now, between 0 and pi over 2, what's happening? So between 0 and pi over 2, the sine theta is increasing from 0 to 1, but you have 1 minus that. So that means r is decreasing from 1 to 0. Am I making sense? So it is actually decreasing here. Between pi over 2 and pi, it is increasing very clearly because between pi over 2 and pi, sine of theta is decreasing from 1 to 0. So 1 minus sine theta will in fact be increasing. And then it's increasing still here, right? And then right at the end, it is decreasing here. Is everyone okay with that? What you need to do is pick some intermediate points and evaluate this r value. So it would be nice to have the values at, say, pi over 4. This would be 3 pi over 4. This would be 5 pi over 4. This would be 7 pi over 4. Okay. If you have a calculator, come up with when sine theta, when theta is pi over 4, 1 minus root 2 over 2. What is that? 1 minus root 2 over 2. One minus root 2 over 2 is what? Was that? 0.29. Let's just say 0.3. And then at 3 pi over 4, sine of that would be what? It's still root 2 over 2, right? So I get 0.3 again here. At 5 pi over 4, sine theta would be what? It will be negative root 2 over 2. So 1 plus root 2 over 2. What is that? Is it 1.3? 1 plus root 2 over 2. 0.3 that I got was 1 minus root 2 over 2. 1.7. And then the last one, this one would be what? 1.7 as well, because it's still negative root 2 over 2. Okay, so we have all these values. Let me see where I kept my... Why don't you guys use this and sketch it yourself right now? And in the meantime, let me find out my... where is my polar coordinates page? Okay, how do I copy it? Let me make a copy of that thing and then I'll draw it. You know what, I'm just going to erase this one. It seems like I'm going to have a tough time to copy it. Do I have that somewhere on my desktop? Hold on. Okay, I'll just erase what I have here. View, full page, erase. I feel bad to erase my art here. What, you guys are laughing? It's not nice enough? Alright. Okay, so someone tell me the values, okay? So here's, let me use green. When t was 0, when theta is 0, what point did we get? What was that? R was 1, so let's take R to be 1, 2, 3, 1 to be here, but then I have to go up to 2, right? So let's take 1, 2, 3. So then let me take this to be 1, okay? And then 1, 2, 3. This length is 1, let's say. So I get 1. And then at pi over 4, what was it? 0.3. So it's about 1/3, right? And at pi over 2, 0, and was that? And then what was the angle then again? 3 pi over 4. Where is 3? 3 pi over 4. The value was what again? 0.3. Okay. And 5 pi over 4, what was the value? Oh, at pi, what was the value? At pi, the value was 1. Okay, at 5 pi over 4, what's that? 1.7. Okay, this is where 1 is. 1, 2, 3. 2 is right here. 1.5 would be here. Okay. This is where 1 is. 1, 2, 3. This is where 2 is, right? So 1.5 is right up about here. So what is that? 1.7? It's pretty close to this blue line, right? Pretty close to the blue line is what? 1.6. So 1.6. So I'll be pretty close to that one. And I think we also have a symmetrically at 7 pi over 4 the same thing. Same thing happens here. But what was 3 pi over 2? Exactly 2. So that's here. Let me erase some of the bad points that I drew here. This one, and I erased the good one. Okay. Is it clear what's going on though? It's pretty clear. You can draw more points if you want to, but it is like this. Okay, so that's how it looks like. I think when we drew 1 plus sine theta, it was pretty similar, but it was probably the other way around, upside down. Everybody's okay with that? Except that I couldn't make my curve nice enough on the two sides, but that's okay. Everybody sees how that's done. Okay. All right, so that's 5A. That's 5. I will give you this in the exam. I'll give you this this polar coordinate page, and that you can use that.